everyone. So in this video, I will be talking about a proof of the Pythagorean theorem. And this person over here is the Greek philosopher and mathematician Pythagoras. And he made the Pythagorean theorem in ancient Greece. But long before that, and the proof I'll be talking about, was made from the ancient Chinese. They made it long before Pythagoras had made his Pythagorean theorem. Because the Pythagorean theorem is an influential and important theorem if you're trying to do geometry. So almost all ancient societies, ancient countries, had to make their own Pythagorean theorem, or invent the Pythagorean theorem. And the ancient Chinese had made the Pythagorean theorem, and they had also come up with a proof for it. And here's how it goes. Let's say you have a large square, and by the way, this is just a Pythagorean theorem. I'm just going to keep it there so you can, as when we get our right answer, we'll get this proof. So with our proof, we should get this. A squared plus b squared equals c squared. So now, back to the proof. We have a large square, and inside it, we have a smaller diagonal square. And each of these sides is either A or B. And B represents the height of the triangle, while A represents this length, the base. So A would take up this length over here, and B would take up this length. And this goes with every side. So like B would take this part, A is taking this part, B will take this part, A will take this part, B is this, and A is that. And in our smaller diagonal square, we have C for each side. So each side has a value of C. So what do we know? Well, the area of this diagonal square will be C squared, since the area of a square is one of its sides, lengths, squared. So the area of the diagonal square is C squared. And the area of the large square, this whole square, would be A plus B squared, because we have A plus B is one side, so that's squared. So we would have the area of the large square is A plus B squared. And we can expand A plus B whole squared, and to do that, since A plus B whole squared is just A plus B times A plus B, and we can use the distributive property to do this. So we have A times A plus B plus B times A plus B. So first we'll do A times A plus B. So A times A is A squared, and A times B would be AB, so plus AB. And B times A is also AB, and B times B is B squared. So we have A squared plus AB plus AB plus B squared. Now we can combine like terms, so AB plus AB equals 2AB, and that's it. So we have expanded it. And A squared plus 2AB plus B squared is the area of the large square. So let's erase this, and we'll write that here. So that's A squared plus 2AB plus B squared. Now what we're going to do in this proof is get the area of the large square and subtract it so we're going to subtract the area of these four triangles from the large square. So we would have the area of this large square, A squared plus 2AB plus B squared, minus the area of the four triangles. And what do we expect? We will expect the area of this diagonal square, which is C squared. Because if you had the large square and took out the triangles, you will have left over the diagonal square. So if we take the area of one of these triangles, well, the base is A, and so the base is A and the height is B. So basically we would have, since the area of a triangle's formula is AB by 2, the area of this triangle is AB by 2, where the A is the base and B is the height. And that goes with all of these triangles, since all of these triangles are the same, they're congruent. And because they all have a height of B and a base of A. And it might not look like that, but if you twisted it around, then it would be the same. So now this has the same area, so we would have 4AB by 2. So 4 times this. And just to make it clear, when you're multiplying a fraction by 4, you can just turn this whole number, 4, into a fraction. So that would be 4 by 1. because 4 by 1 is 4. So we could just write it like this. And now we know that to multiply fractions, you can just do horizontally. So you would have 4ab by 2. And we can factor this since both have a common factor of 2. So we could say that this is 4 would go to 2 and 2 can be 1 because you can divide the numerator and denominator by 2. So we would have 2ab. And you probably don't see the 1 because that doesn't matter. That's 2ab by 1 is 2ab. So we have 2ab. Now we're going to subtract this from the area of the large square. So yeah, the area of the large square is a squared plus 2ab plus b squared, and that minus 2ab. A squared plus 2ab plus b squared minus 2ab should equal c squared. Well, we can, since 2ab and 2ab are like terms, 2ab minus 2ab would be 0, so we can cross those off. And we get a squared plus b squared equals c squared. We deserve some fireworks. Well, we have successfully proved that the Pythagorean theorem a squared plus b squared equals c squared is true. Bye!